It is stunning to see this sunset that was taking place out into Oak Ridge, Oregon, but you can see it's a little bit hazy out there. Still a beautiful view with all those colors, but the hazy skies is all thanks to some of the smoke built in from these western wildfires. Now we're still tracking quite a few fires out west, out into portions of Washington. We've got the Vantage and Cow Canyon fire out into portions of California. We've got a few fires. The McKinney fire is sitting at over 60,000 acres, 55% containment there. The Moose fire has risen to over 71,000 acres and is 17% contained. So still a lot with these ongoing fires, and they continue to build up some of that smoke in the area, creating some hazy skies, lowering air quality at times as well, especially for those of you that are more prone to sensitivity. So as we look at the air quality from our morning hours out near places like Redding up through Eugene, we have been seeing some areas reaching unhealthy air quality. So generally unhealthy for sensitive groups, but as we head into unhealthy under the red category, that can be felt by the general public, not just those that are more prone to respiratory issues. We hold on to elevated fire conditions here with red flag warnings in place throughout portions of Oregon, and this can affect some of our sunrises, sunsets when it comes to some of those smoky skies. Here's more on the science behind it. From the simplest question, why is the sky blue, to how the colors of sunrises and sunsets vary day to day, it's all due to one phenomenon, Rayleigh scattering. Sunlight is made up of all the colors in the visible light spectrum, but not all the colors reach the Earth in the same concentration. Blue and violet are a shorter wavelength, meaning they are easily scattered across the atmosphere. Blue waves will bounce off of molecules in the air in all directions during the day. This creates the blue skies we see. As the sun rises or sets along the horizon, the light travels a greater distance through more particles to get to your eye. The shorter wavelengths get filtered out, and the longer ones, like reds, oranges, and yellows, reach your line of sight, giving us some magnificent views. Of course, atmospheric conditions vary daily, meaning not all sunrises and sunsets will look the same. In winter months, humidity is typically lower. With fewer water molecules, there is less of a barrier for light to pass through. The result, brighter skies. The role of cloud cover is also a delicate balance. Think of clouds as catching the light like a projection screen and reflecting them back, which can make for even more spectacular views. And what about those daunting end-of-the-world-like skies we saw over San Francisco when 500,000 acres were ablaze nearby? With wildfires, it's also a particle game. Smoke molecules are much larger than typical gas molecules in the atmosphere and better scatter the longer wavelengths of light. So the next time you're enjoying the atmosphere at work, maybe you'll think of Lord Rayleigh, who termed the science behind the phenomenon. For Weather Nation, I'm meteorologist Taban Sharifi.